Let's write down all our theorems. There. 9.8 power series. There's a definition of power series. If X is a variable, then an infinite series of the form an times x to the n is equal to a0 plus a1x plus a2x2 or x squared plus a3x cubed all the way until an to the xn and so and beyond. So this is called a power series. More generally, an infinite series of the form and an times x minus c to the n equals a0 plus a1 times x minus c plus a2 times x minus c squared all the way to an times x minus c to the n and beyond. C is a constant, by the way. Oh, hold on a second. Yeah, let me phrase it there. So this is called a power series centered at C, where C is a constant. Okay, for this definition of power series, now let me give you the theorem that tells you about convergence of power series. The convergence of a power series a power series centered at C, precisely one of the following is true. One. The series converges only at C. Number two. Are you cool with the math symbols? Just to shorten this up, there exists an element of the real numbers. It's just that R is greater than 0. Oops, put that weird. Such that the series converges absolutely for x minus c less than r, and diverges for x minus c greater than r. Write that a little bit better for you. There exists an R such that R is an element of the real numbers, and R is greater than 0. That's more proper. So the backwards E thing is exists, and I'm referring to the R that is a real number that is greater than 0. Number 3, the series converges absolutely for all x the number R is the radius of convergence of the power series. If the series converges only at C, then the radius R is equal to 0. If the series converges for all x, then R would be infinite, right? And the set of all values of x for which the power series converges is called the interval of convergence of the power series. Okay. To shorten up number 3, I guess I could say this, just so you can refer to it easier. If converges only at C, then R equals 0. And the interval would be just that number, C. If it converges for x minus C less than R, then I is equal to C minus R, and all the way up until C plus R. And the R would be equal to that distance. How big is that interval? Okay. So let's say you converge from -2 to 2, then the radius would be what? What's the distance? From -2 to 2, that distance would be what? 4, huh? Total. But the radius would be 2, which is true. Because you'd be right in the middle. So going outward would be 2 and 2. So just try to figure that out when you find this interval. Converges for all x values, then R is infinite, and the interval would be -infinity to infinity. That's what number 3 is basically. What's up?
What is that term? How do you say that term? The A upside down?
Oh, this means for all.
What is that?
Let me write it up here.
Yeah, I never heard of that. Never seen
So this
it.
means for all.
For all.
This means there exists.
Ah, okay.
I try not to use them because I'm not sure if everyone has seen them, but it's shortened to
Yeah. I know.
the theorems.
All right.
So this is
Thanks.
saying that there exists one R that isn't a real number, right? And you're familiar with the epsilon, right? The E.
I've seen it, but I don't remember.
That little epsilon means element of or part of. So this is saying that R is from the real numbers. So there exists an R that is in the real numbers that is greater than 0. So all those are required for this statement.
Got it.
Find the radius of convergence of the series n factorial times x to the n. So this one is centered at 0, right? See how there's no x minus c? So c is 0 here. Also, for the power series, you're pretty much going to do ratio and root the whole time. It's very rare that we do anything else. Because ratio and root will create that interval of convergence. Remember how it has to be less than 1. So when we're doing it, you're going to create an interval. But let's go ahead and do the ratio test. So and is this guy. N plus 1 is equal to n plus 1 factorial x to the n plus 1. So the limit of an plus 1 over an, technically absolute value, but it doesn't matter for this case, going to equal the limit of this guy here over n factorial times x to the n. So let's do some algebra. So this will be the same as saying n plus 1 times n factorial. I'm going to break a piece out here of xn times x, right? That's the same as xn plus 1. Now I can cancel these terms. These are So what we have left is the limit of n plus 1 times x over nothing actually. Okay. I'm going to put my absolute values on there because I just realized that I don't know what the hell x is. X could be negative, I guess. I don't think they stated. So I'll be left with n plus 1 times x. What is that limit? X is some number. But as n grows, some number times that is still infinity, right? So this limit is infinite. So this means this series sorry, let me look at the let me get my ratio test out. Let me check my book on this. I feel like it should diverge, except when x is 0. My notes say otherwise. second. Almost found my book. So this means the series diverges for all x except when x is equal to 0. Because if it's 0, right, the limit would be 0. So that's the only place it converges. So this only converges which means that our radius is also visibility. Okay. Does that make sense?
The equal to a field, or the specific line or the result, what it's a field or what the,
Second one?
yeah, the result.
Yeah.
Yeah.
That's n plus 1 times x.
Oh, that's the
Yeah, infinity. Looks like glasses or something. Let's do another one. Find the radius of convergence for -1 to the n times x to the 2n plus 1 over 2n plus 1 factorial. Okay. So I'm going to ignore the alternating part because technically the ratio test has absolute values built in. So it's not a big deal to ignore it. So if you plug in the m plus 1, I distribute the 2, right? And then add 1, because that was already built in. So we're going to get 2n plus 3, which is the same for this down denominator part. 2n plus 3. Right? So take the limit of an plus 1 over an as n goes to infinity. That will be the limit. I'm going to skip the algebra step. X to the 2n plus 3 over 2n plus 3 times the reciprocal, so that'll be 2n plus 1 over x to the 2n plus 1. So that'll be x to the 2n times x cubed, right? Times 2n plus 1 over, and this one I'm gonna have to expand a little bit more to get to 1. So this would be start at 3, 2, and then 1. Over here I'll have x to the 2n times x. So that's my 2n plus 1 right here, right? So that will cancel this guy, cancel one of those, cancel the factorial. So that will leave me with leaves me with x squared over 2n plus 3, 2n plus 2, right? What is that limit? Would be yeah. Does it matter what x is? X is some real number, right? It doesn't matter what it is. The limit will always be 0. So what does that mean? It does converge. That's true. But the radius of convergence will be for all x, right? Because x does not have any effect on the limit. This means that power series converges for all x in R. So the radius would be infinite. The interval would be from here to here. They haven't asked for the interval yet, but eventually we're going to have to find it. So we're using the ratio test. Technically, I should show a little extra step here. Well, I can say it down here. Since the limit of an plus 1 over an is equal to 0, which is less than 1, then that's why it converges. So by the ratio test. Any questions on number 1 or number 2?
So you found that it converges using the ratio test, and then there.
Yeah, the goal here, so we have a power series, right? So we treat them like we do all the other series, but there's a variable x now that could affect the convergence. So we use the ratio test to tell us how does the x affect the interval. Okay, so it's possible the x doesn't matter, and if that's the case, then we can play whatever we want. Like here, that means that all x's are allowed. In the first example, it only converged when x was 0, meaning it was only a single spot. So the range, or sorry, the radius was equal to 0, so it didn't go anywhere. This time it goes everywhere. And we also have, I think, the next example, a specific set of numbers. The other scenario. You guys go on this page? Radius of convergence of the series here. But notice how it's no longer centered at 0. So here we'll have a different type of interval. But notice that we don't have to do ratio here, right? We could do the root test. They have the same, what's it called? Rules. So we can create an interval of convergence using the ratio or the root test. Doesn't matter. One or the other. Or power series. I'm gonna do root just for fun. So an is going to be 3 times x minus 2 to the n. So the nth root. That's right limit. You're gonna need to learn how to write my left hand. Take turns. The limit n approaches infinity of the nth root 3 times x minus 2 to the n. Which is equal to the limit then approaches infinity of 3 to the 1 over n. If I change it to roots, or change the root to a power, you would have to apply to each part though, right? So I skipped 2 steps there. Is that cool? Now there's steps. So if we take the limit, well, first of all, these are going to cancel, right? Take the limit, what's going to happen to that 3? Well, first of all, what will happen to the power? Right, this power will go to 1.
To 0?
Yeah, this is going to be 0 here. 3 to the 0. It's going to be 1, right? Now, this limit must be, oh, I forgot my absolute values. It must be less than 1 in order to converge, right? So, solving inequality is what we're going to end up doing. You guys remember how you remove absolute value? But if it's a variable, it could be, x could be anything, right? Right, back in, I think we did it back in college algebra. We said absolute value of less than 1 is the same as saying it's between 1 and negative 1. So for x, I'm going to add 2 to all 3 sides. So I get 1, 3. Does that make sense? Let me do plus 2, plus 2. So this right here is the interval of convergence, although I do not know if the endpoints are okay. I only know the inside's fine. So I'm gonna have to test for it. But right now we have a section that's good. In between is fine. Okay. What is the radius? And how far is it from the center? So 3 and 1. The total is 2, right? So radius would be. Right. So let me write you a note here. So each endpoint must be tested separately for convergence. Or divergence. So let's test x equal to 1. So I can include that. So instead of less than, I say equals. So is this series is that going to converge?
Yes.
What is the first few points? Right, it's going to be 3, -3, 3, negative. Right. So it doesn't stop at a single point, does it? Remember we said that if we do the divergent test, we take the AN, the limit of AN must be 0. And does not exist. The limit does not exist, so therefore diverges by divergent test. So we cannot include the 1. So now let's check the 3. Before we move on, is there any questions on this idea here? Do you see why it diverges? Right? There's no limit. It will alternate forever. You would have two different limits. So it doesn't exist. All right, now let's do the other one. So 3 minus 2, so let x be 3. I'm going to get 1 to the n, right? What's that limit going to be? Yeah. And we said that if the limit is not zero, what happens for divergent test? It's required for the limit of the sequence to go to zero. If it does not, then that series will diverge. The limit of 3 times 1 to the n is finite. It's just cool, I guess. But this means diverges. I think I read that better. So since the limit of an is not equal to 0, then the series of an diverges by the divergent test. So that's what I did over here. I just didn't write it very well. Okay, so this is 2 parts here. So now we know the interval of convergence, even though they didn't technically ask for it. I don't think. I want to, might as well do it now because they're going to ask. The interval will be parentheses 1 to 3, not brackets. If I would have plugged it in and they converged, then you would put a bracket on one or both. That makes sense? So that's pretty much it for power series. It either converges to one point, converges nowhere, or everywhere, or some small little small interval. But you see how the interval will be created by this requirement that this must be less than 1, right? From the root test, which is the same as the ratio. Any questions on 1, 2, or 3?
You scroll it up a little bit. I need to see something on top.
Okay.
There you go, right there is perfect. Got it. Thank you.
Okay. Let's look at the schedule. This is the week we're on. I think I can do this next week and then review and go from there. Yeah, we'll stop here. You guys have any questions about RCs? This section might seem more difficult if you haven't practiced the ratio and root. So I don't know, you guys might be a little focused on chapter 8. I'm hoping it at least makes sense. If not, please bring questions next week. Okay. It's my favorite chapter.